So what I have here is a 135-gram steel ball, and I'm going to use this with this inclined plane to impact several pieces of glass. And the first piece of glass that I have here is a competitive aluminosilicate glass, and it's been scratched right here in the middle. It's 0.8 millimeters thick. And what we're going to do is take this glass sample, we're going to load it into our holder. We're going to go ahead and let this ball impact that glass sample, and everybody to keep a close eye. We have a view screen up here so you can see what happens. That glass sample just broke. You can hold that up for everybody so you can see. This was damaged with a 7-Newton scratch from a diamond tip and broke during that ball impact. Well, let's try the same thing with Corning Gorilla Glass 3 with native damage resistance. The first thing that we want to note is that there is a scratch here, but it's very, very difficult to see. And that's part of what I showed you in some of the pictures earlier during the presentation. We're going to go ahead and load this in. We're going to let that drop. And that glass sample is going to survive. It did not break. It's still intact. Again, damaged in the same way. You should also note this sample is 0.7 millimeters thick. So it's a little bit thinner than that competitive glass that I just showed you. But that's not good enough for us. We're going to ramp it up a little bit higher because we want to show the enhanced retained strength of Corning Gorilla Glass 3 with native damage resistance. So what I have here in this holder is an aluminum sheet that's 0.77 millimeters thick. And what we're going to use this aluminum sheet for is to show you the amount of energy we're imparting into the glass during this impact event. So I'm going to go ahead and let this go. We're talking 3 times more energy than the first incline that we looked at. And you can see, even in the video here, up on the screen, the dent in the aluminum plate. This is a substantial amount of energy being imparted into this piece of glass that we're going to test next. So let's do it with Corning Gorilla Glass 3. We'll load that sample. We'll go ahead and let the ball go. Even with the rebound, it's still intact, no failure. Again, that's the 7-Newton scratch from a diamond. Still intact after that ball impact. But that's not even good enough there. We're going to go one more step further. We're going to take the sample out. We're going to put it into this ring-on-ring press. And what this does is take 2 concentric rings and basically puts a whole lot of force in the center of this sample right on that scratch. And what we're going to do is put up to 100 pounds of force on that scratch to show that that glass can still withstand that kind of loading. Here we are, up over 100 pounds of force being put on that glass sample. Even with a scratch, it's still intact.